Assalamu alaikum. Today we will talk about operations on functions. Simply, operations include addition, subtraction, division, and multiplication. And adding two functions is just as simple as adding two expressions. For example, adding like x to the power 2 positive 2x to x to the power 2 positive 3. So addition, subtraction, multiplication, and division are just the same thing. But the point is getting the domain of the resulting function. What will be the domain of the resulting function? For example, if this is f of x and this is d of x, those are two functions. And we have d1 for f of x and we have d2 for gx. Now, the common part between both of these domains will be the domain of the resulting function. So if we draw the two domains on the number line as an interval, for example, the domain of the first function will be r positive. So to be all the numbers here and not including the 0. This is positive infinity and this is negative infinity. So this is d1. And d2 will be, let's say, from 1 to negative 4. So it will include all the numbers from 1 to 4. This will be a closed interval. And this will be half opened. Or opened from not including the 0 to positive infinity. So the domain of the resulting function of addition, subtraction, multiplication, division, all of these, they follow the same rule. The will be the common part. So simply it's d1 intersecting d2 and not the union of d1 and d2, because if we take the union of both domains and we want to substitute, for example, in one of the functions or in the resulting functions with negative 3 or with 0 or whatever, any number not included in this part, the result will not be correct. So we take the intersection point between both of the domains. Now the result here will be 2x to the power 2 plus 2x plus 3, and the domain will be from open 0 to closed 1. This will be our domain. This is the rule for addition, subtraction, and multiplication. There is a little difference in division, and we will know why. So d1 equals that interval and d2 equals from negative 4 to 1. Now let's subtract this function from that one. So we get x to the power 2 positive 2x negative x to the power 2 negative 3. So we get 2x negative 3, and the domain is the same as that one. And if we multiply these together, we have x to the power 2 plus 2x. Here we have x to the power 2 plus 3. So we get x to the power 4. Multiply this by this, then this by this one. We get 2x to the power 3. And then we multiply the 3 by the x to the power 2, so we get 3x to the power 2. And then here we get 6x. So the result will be, here we have x to the power 4 plus 2x to the power 3 plus 3x to the power 2 plus 6x. And the domain will be the same as that one. But in division, for example, dividing fx by dx, so we will have x to the power 2 positive 2x over x to the power 2 positive 3. Now, here we have a function so that if x equals root 3, here the result will be a 0 in the denominator. So the result will be undefined because we'll have a number divided by 0. So the domain of the resulting function will be the same as that one, negative the set of zeros of the denominator of the function in the denominator. So the domain will be like that. 0 to 1, negative root 3. But there is a very important note. Here, the root 3 actually equals 1.7. So 1.7 is not included already in this interval. So we don't write this. If the set of zeros is not already included in the interval, so we don't have to exclude it from this interval, so we don't write it. But if the set of zeros is included in this interval, so that somebody may substitute with it in the equation and the result will be undefined. So we exclude it in order to let know that this number will not be used in substitution in this equation. So here we don't have the root 3. And that's it for today, and until the next time, thank you for watching and see you. Assalamu alaikum.